All right, so this one's going to be basic concepts in geometry, and the thing that I want you guys getting used to is it's a little different because I'm sure in other math classes you guys are always focused on the numbers, but in this class you really want to start focusing on the vocabulary. Like you even do it in other math classes. Like for example, when you guys took algebra, you had to know what a slope was. You had to know what rise over run was. In geometry, it's heavily English based. So a lot of people who are usually good with the math start struggling when they get to geometry because it's very language focused. And I want you guys scaring you. I'm a numbers guy too. I'm not a very good English person, but geometry is one of those things that got me better at learning vocabulary and it got me better at English. So that's why this is a very definition focused lesson. So we're going to learn about what is an angle, what's a circle, what's a perpendicular line, what's a parallel line, and what's a line segment. And all of these are really focused on the mastery test. So make sure you're watching out for these definitions. I don't think I talked about it so much in the first lesson, but always look at your summary, your intro. Well, the introduction is just that one video. I finally took a look at them and I'm like, that's not that important. But these objectives are very important because it tells you what you have to take away from this. And this is what the mastery tests are going to be based off of on whatever's in the objective. If you finish a tutorial and you do not remember what the definition of an angle was, a circle, a perpendicular line, a parallel line, or a line segment, that means you're probably going to have a hard time with the tutorial. So you should go back and make sure you're taking notes, you're writing that stuff down. Especially later on once we start getting into theorems and equations. So, Daniel, I don't know if you saw this last time, but you can actually turn that off. That way you don't have to worry about it. You can click on here, turn off slide narration, and then it'll never do that again. So this little speaker guy right here, where it says reading tools, this guy talking, click here, turn that off, and then it'll stop. You won't hear it talking anymore. That way you don't have to worry about it. And you can do that for all of your classes. That way you don't have to worry about it. I mean, you can always turn it back on if you're like, I don't want to read this. I'm going to like clean my room and have it reading to me, especially on those history classes where it's a lot of reading. But that way, you don't have to listen to it every single time for something like math. All right. So introduction. So when we're talking about this, we're just talking about pictures, how we see this in real life, how architects see it. So when we're using shapes and stuff in real life scenarios, we need to know what those shapes are and how we can reflect that later. So right now we're talking about 2D. So we can see this is a 3D model, but everything in 3D kind of has a layout. So this is like the base plan of this floor, but then you can also see it from different perspectives. So that's what geometry is. It's kind of taking 3D and we're going to put it in 2D and eventually we can put all those images together to make that 3D idea. Oh shoot! I am so sorry. I I started the recording, but I forgot I wasn't screen sharing. So oh my gosh, cool. Thank you. So I was highlighting all of these things with the objectives. So before, so when I was talking about the objectives, I was highlighting this. So whenever you see objectives, make sure that you're looking at this and you know what you're getting into before you start a lesson. Thank you for pointing that out, Alex. That's really helpful. And this was the little speaker I was talking to you guys about. I'm so sorry. So you go to this little guy right here where it says reading tools, click it, and turn that off. So that'll help you be able to not have to listen to it if you don't want to listen to it. If you want to listen to it, you can always turn it back on. All right, and this is what I was talking about when I was talking about those 3D and the 2D shapes. All right, so now it's a good thing you pointed that out before we got to this part. So now we're going to talk about line segments. So it's important to know the definition between a line and a line segment. So a line that we learned, what you guys are used to from algebra. Let me sign in here real quick because I was using it somewhere else. So this one. Okay. So a line, what you guys are used to in Algebra 1 is this idea of something that has a rise over run that goes on forever, basically. It never stops. That's why usually you draw arrows on it. A line segment, though, ends. It has a starting point and an end point. So in this case, you can see this A as a starting point, or you can see it as an end point if you're assuming the B is a starting point. So remember that ruler position postulate? It says that any point can be your starting point. So you can start at B and go all the way to A. And this case, you can start at C, go to D, or you can start at D and go to C. What in geometry, the way we write it down is we want to make sure that wherever we're starting starts off on the left as we go to the right. So we're in this line, we're saying A is our starting point. But if I wrote this way, would say B is my starting point. That doesn't matter right now, but it will matter later. So make sure you understand how we annotate stuff. So it kind of matters when we're doing something like this. You'll see it in GeoGebra a lot too. If we're saying that our angle is A, B, C, we're saying we start off at A, we go to angle B, and then we go to point C. So we're going from A to B to C. And in GeoGebra, the reason why I say this is important is because GeoGebra, when you're measuring an angle, it only does counterclockwise. So you want to make sure you're going this way. So when you're doing this, the correct way of doing it is A to B to C. If you do GeoGebra and you do A to B, or C, B, C, B, A, what it'll do is it's assuming you're talking about this angle right here. And you'll see what I mean as we get into later sections. So let's move on to this. So now we're going to use the tool GeoGebra. So the instructions are here, but if you guys are having trouble reading these, because honestly, I've read these before, and I've used GeoGebra like when it was brand new, when it was a new tool. This program's actually pretty old. This is kind of boring, to be honest, especially if you have no idea what you're doing. Like you're looking at these and it's like, well, I just want to make a line, and you're like, well, which one of these tools do I use? And you have to like look at all of these things. So if you guys ever need help, you can just make an appointment with me. Like, hey, I just want to figure out how I can make angle with a specific angle, and we can talk about it. But that's what these classes are going to be for. We're going to teach you how to use GeoGebra and stuff like that, as well as learning the concepts too. So that's the instructions. It's usually going to be in every Edmentum slide that requires you to use GeoGebra. So let's, and also it's going to have GeoGebra itself. So what we're going to do here is if we open up GeoGebra, it opens up this. Now, one thing I want you guys to do is make an account. And the way you make an account, it's not going to do it for me, but what you do is you go here, you click share, and what's going to pop up is it's going to tell you to make an account. Make an account with your student account. So if you look here, I'm sure there's a way for me to see it. If I go to GeoGebra, basically I have an account, but when you click share, it doesn't let you share unless you have an account. So later on, I'll release a video on YouTube later, how to make a GeoGebra account. But you want to do it with your student account because, like I said, the teachers are going to start collecting these links. So when you go here, click these dots, hit share, name it after the activity that you're doing. So in this case, we're doing lesson activity for basic geometry tutorial. So I'm going to do this, copy this, go into my GeoGebra, I'm going to paste it, and I'm going to go lesson activity. That way I know exactly which activity this is. If you want, write your name on it too. When you click save, what it does is it saves whatever you were doing there, and it gives you this link. And then you can just copy that link and paste it here. If I were to go to this link, it's just going to show a blank screen right now because I didn't save anything. So if I go, yeah, I can get rid of this. If I go here, unfortunately, it takes a while that you see my blank screen, which I guess isn't impressive. But let's say I made a circle and I save this. So I click save. I'm going to save it to that thing. If I go over to this screen where I had it, where did I put it? Well, let's get that shareable link. So I'm getting the link. It automatically shares it now that I made a file. Copy. I'm going to go over here. I'm going to paste this. You can see my circle. So that's the main idea that I want you guys getting used to is instead of having a screenshot, we're going to start sharing the things. So let's see what this assignment wants us to do. So it says plot 3 points and label them A, B, C. Well, we don't, GeoGebra is actually really nice and we don't have to label them when we're doing this. So what we do here is I can use the little arrow to kind of delete my circle. And it wants me to plot 3 points. So what I'm going to do here is I'm going to click this little thing. This little dot is my points. 1, 2, 3. Those are my 3 points. They're labeled A, B, C already for me. Be sure that these points do not make a straight line. So any 2 points make a line. So I just have to make sure all 3 of them do not make a line. So here we go. So I'm doing this. And now it's saying, now join the points at a time using straight paths. These straight paths, 2 points. So what it wants us to do there, it's saying straight path, but what it's asking us to do is essentially a line segment. So we go here, don't click line, those go on forever. Click line segment, click your A, click your B, click your B, click your C. Now we have like a little path that we're doing here. We have 2 line segments because we're making a path. And then what I'm going to do is if I want to share this, I'm going to click share. Because I already saved the name, it doesn't require me to name it again. Then I click copy. I'm going to paste it here. So any teacher can go to that link. Any person can go to that link and see the activity. And because it's saved under your account, we know that you're the one that made that object. So now we're going to go to 3 paths. Oh, 3 paths. Okay, so it wants us to make a triangle, basically. There we go. All right, so the 3 paths, and if you edit something and you want it to be saved, make sure to go back and save it. All right, and so the 3 points path, measure these things using the measuring tool. So the measuring tool is this thing right here. This measures anything. It can measure an angle. It can measure how long something is. It can even measure area or slope. So we're going to measure an angle. So remember what I said, we have to go counterclockwise. So if I want this angle right here, this angle C, I need to go from B or from A to B, right? Because that's counterclockwise. So I want to go A, C, B. Now notice what happens if I go the other way. B, C, A. It makes it the other angle, which is what I don't want to do. So I'm going to undo that because that's not what I want. So if I want angle B, I want to go from C all the way to A because I'm going counterclockwise. So if I want to go from C to A, I'm going to measure tool. It's already highlighted. C, B, A. If I want angle A, I want to go from C to B because again, counterclockwise. I'm going this way. So I'm going to go C, A, oops, I did it the wrong way. This always gets me counterclockwise. This is clockwise. So I want to go from here to there. So it takes a while getting used to this, guys, but just remember there's always the undo button. And apparently I didn't click this right. So there. So it's just a matter of kind of getting used to where we're going. So that's going to give me my measuring tool. And then I want to save this image. So I'm going to save this image as something else. I'm going to save it as question 2. So what this is doing by doing save as, this is leaving the other one the same. So if I do this, this is a brand new link. Oh, actually, is it the same link? It's supposed to be a brand new link, but they'll just see that you're progressing through it. But as you get different ones, they're going to create different links for you. So, uh, the 3 lines pass ABC points represent the intersection. However, explain the difference in terms of angles you see. Also, look at the length of the opposite angles. What pattern do you see regarding the measurements? Make a point. Make each point. Which of the following differs each other? Explain the difference in terms of angles. Okay, so it wants us to say the angles. Also look at the lengths of the opposite sides. So in order to look at the lengths, the step they didn't tell us, or were we supposed to do it here? No, they didn't tell us to do it. They're saying compare the lengths. So just to make it easier for us, I'm just going to measure how long the lengths are. So that's this thing right here, distance or length. A to C, and then I'm going B, C, B, and I'm going this. And let's say these are like in spots you do not want. You can just move these around to a spot like you would want them at using the little arrow right here. So this lets us compare it. So if I look at this, I'm looking at this angle 39, or let's take a look at this one actually. If I look here, I see this really big angle, and the side opposite of it is the biggest out of all of them. So the biggest angle is opposite of the biggest side. And this small angle is opposite of the smallest side. So what they want you to do here is they want you to write something along the lines of small angles course are opposite of the smallest side. So that's what it means by what observation do you do. Now I want you to write that in your own words since we're doing it together, and also ask you to modify your triangle. So let's say I move my angle. Let's say I want to make my angle A and I want to make this really big. So I'm going to move this here and I make this really long. So if you look here, all of a sudden this becomes smaller because all of a sudden it's not the biggest side. So if I keep making this longer, if I keep making this longer and longer and longer, and I'm not using my arrow, that's what's going on here. If I keep making this longer, 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 that makes that bigger. All right. Does that make sense, guys? Cool. So here, what they're gonna want us to do is we're gonna start a brand new GeoGebra. So use GeoGebra to make these points. We want to make them on these specific sides, and they want us to measure the angle and everything. So this, let's say we want to do that way. So what we can do here, I'm going to start a brand new GeoGebra. So I can just go to the top of my screen, click, where's GeoGebra? Oh, go to open GeoGebra. Now I have a brand new screen. I'm going to save what I did over here. That way my work is saved. So anytime you save your work, it's going to change the work you have saved on that link. So now I'm starting a brand new GeoGebra, and it wants us to make these points. So what we can do here is we can just click where we want them. So it wants it on the points 3, 4. So if we go here, we're going to go to 3. Always remember your X goes first. We're going to go to 3 up to 4. We're going to go to 1 and 1. So then we go to 1 and 1. We're going to go to 5 and 1. So this is going to take a while, guys. But after you get these done, you get this. You're going to want to make your line segments here to here, here to here, here to here. And then you're going to want to measure all of your sides. So go to your distance, measure your sides, measure your side, measure your side, and then measure your angles. And make sure you're measuring the inside angles, not the outside angles. So you're going to want to remind yourself, go counterclockwise when you're measuring those angles. So just to save time, because we only have an hour, I'm not going to go through all of these. Make sure you go through all of these because the practice is going to be vital to when you guys have to do the unit activities. I'll give hints on how to do the unit activities. Like I'll make videos and post them on the Google Classroom. But you're going to want to make sure you're doing your tutorials all the way through because it's going to help you do those unit activities. So here you're going to want to measure. This is going to be the length. You're going to measure, record what AB is, what this is, what this is. Record your angle, record your angle, record your angle. And you're going to do that for all three of these triangles. So now it's saying move point B and C along. Notice the change. So we're going to record what happens when I make it B and C longer. What happens to angle AB. So if I'm measuring this and I want to move this, one of the, which one does it want us? Oh, either one. So we can move either. So we're going to want to move C towards B. So we want to make it a smaller line. What happens to angle ABC? So angle ABC is this angle. So if all I do is if I just move this closer, not changing it anyway, we see that this angle would stay the same. I didn't record the angle, so let me actually record it. Counterclockwise, so I want to go this way. So I want to go C, B, A. And it honestly depends how you make your triangle. So sometimes these are going to tell you angle ABC, but it's really CBA because I decided to make my C go over here instead of making my B go over here. So just keep that in mind. So if you see here, my angle pretty much stays the same. The only reason why it's kind of changing is because my hand's kind of shaking. I can't make the mouse go perfectly still, but my angle stays the same. Then it's asking me what's happening to angle BAC. So in other words, angle A, whatever's in the middle is basically the angle that we're talking about. So we're asking what's happening to angle A. So angle A is this angle. This angle, as we make it smaller, this angle should be getting smaller too. I'm not going to record it, but you can visually see that the angle gets smaller. And then it's going to ask, what's happening to angle C? Well, if you do this, you can see that angle C is actually getting bigger and bigger and bigger the closer we get. So that's what it wants us to do for this one. And then it's like delete AC and focus on BC and that. So we're going to delete AC. So I'm going to move this back over here. Let me move these over here. So I'm just going to click this little line segment, hit the delete on my laptop, and this lets me just focus on only this angle B. All right, and changes. What happens when you increase or decrease this thing? So if we increase or decrease these lines, again, like I said, it stays the same. Like I said, it only moves a little bit because I can't make a perfect diagonal movement, but for the most part, it stays the same. You can even write that down on your response. For the most part, the angle stays the same. If not, it changes a little bit because again, I can't I'm human. I can't make this angle stay straight and keep making it on a perfect straight line. And then you're just going to evaluate how you did. So if you're having trouble with the tools, this is a good spot to kind of write down what's hard about GeoGebra for you. So now we're going to talk about line segments. So this is what I was talking about before, how it doesn't matter if you call it AB or BA, the measurement is still the same. It's still 3 centimeters long or 3 units long. The reason why they use units is they're like, in case you're using centimeters, in case you're using feet, in case you're using inches, they just call it the unit. So that's just this idea that you can just change these two and it'll be fine. Similarly to this, you can technically change the C and the A, and they'll be fine too. It's still talking about angle B. So this is just talking about the measurement. So whenever we talk about the measurement of an angle, we're talking about the degrees. If you ever just see this symbol, it's talking about the angle itself. And that's a big key difference because let's say if we're talking about the measurement of angle A, B, C, we can say this is like, I don't know, 45 degrees, for example. But if we say that angle ABC is equal to, let's say I said angle DEF, without putting this measurement thing in here, this is wrong because it's saying that there's another line here, there's another angle here that's the same angle. Like these angles are the same, which isn't right. What we're referring to, if we had the DEF over here, we want to say the measurement of the angles is the same. I know it seems picky, but when you're doing proofs, that matters. Whether we're saying that the angle is the exact same angle or whether we're just talking about the measurement of that angle. So that's just this little key difference here. It isn't on the mastery test, but it is important to know that moving forward. Oh, and one thing I forgot to mention is a straight line is always 180 degrees. So if it's a perfect, so if all 3 points make a straight line, it's going to make a 100-degree angle. Yeah. All right. And then here, if point D is placed on AC, so if we put a point D on AC, let's say I'm putting it here, how will the measurement of angle DAB be? So DAB be compared to angle CAB. So angle CAB. Well, they're the same angle. The only reason I should overlap it, I guess. So they're the same angle, right? This is angle that, and then we have the exact same angle. So they're going to be exactly the same because the measurement is exactly the same. So this is one of those rare cases where the measurement and the angle really are the same thing. The only difference is the endpoint. But the endpoint doesn't matter when we're talking about that. So I guess in that case, let me retract that statement. These are not the same angle because it doesn't have the same endpoint. All right. Are angles making sense to you guys? Oh, and by the way, just to prove to you that I wasn't making it up, it's right. All right. So now we're going to talk about circles. So circles are kind of interesting. What circles are, it's a point here called the center, and then all the points around it. So let's say I had a ruler and I measured from here to here. This would be like, let's say this was 3. That means if I get a ruler from here to here, this should also be 3. So this is known as the radius. So a circle is always a center that it's equidistant. Equidistance meaning equal distance, obviously. So it's always the center is always equidistant to any point on the circle. So think of a circle as it's just someone getting a ruler and measuring every little dot over and over and over again until eventually it makes a complete perfect circle. That's where the idea of a compass is. Like you guys might have seen them in school, these things that do here. This is technically a measurement and it goes all the way around to make a circle. All right, so when we're doing this lesson activity, using the geometry tools to open up Geogebra, we're going to start a point at 0.05 and we want a distance of 4. So this actually isn't that hard to do. What we're going to do, it wants you to copy and paste the image, but I already showed you guys how to copy and paste the link. So I want you guys doing that instead. So we're going to open up Geogebra. Like I said, there's always a way to open up Geogebra here. and we want to make it at 0.55. So you can kind of, if you have a mouse, you can scroll out. If you don't, you can always, how can you scroll out? So, hmm, there should be a way. Well, usually these things should be fine, but you can always input a point here if you're having doubts. But I don't recommend that because you can just usually just click your point, go here, go to 5, 5. So here's my center, and it wants me to make a distance of 4. So what I'm going to do is I'm going to go to this circle and center tool. I'm going to click this right here. I'm going to make sure my A is my center, and it wants a distance of 4. So 1, 2, 3, 4. And I can measure that anywhere. I can go 1, 2, 3, 4, and you see it's still over here. So there's my distance of 4 units. Then we're going to copy and paste that picture. So in other words, go to share, save it as activity 2 for the first tutorial. Just give it a name so we know that it's different. And then after that, it's going to save it, copy the link, and paste it right here. And as you can see, it's a different link than that first picture I meant. Now it's saying create a circle such that it's A and B um, in the point. Oh, capture it. Oh, I'm sorry. So I think they wanted us to do this tool. I don't care if you do it this way or the other way. There's another tool here where you can literally just make the circle, and it's like, how big is your radius? And you just say 4, and you can't see it, but let me hide the circle. So here's no circle. Here's one circle. Hide it again. Here's the other circle. It's the exact same thing. Just one way I did it with 2 points. The other way I did it with the other points. So it's basically the same thing. It's just like make a brand new circle is what it wants you to do on question 2. So I can just paste my link again because it's basically the same thing. In questions 2 and 3, what's the difference in the circle? So there's a thing in algebra where I don't expect you guys to have this memorized. In fact, you can Google it, like equation of a circle. It's this thing right here. This H would be our center. This K is this H is the X value of our center. This K is the Y value of our center. And this is our radius. So that's all a circle is. And GeoGebra is actually really cool. It actually shows you right here your radius squared. So if you take the square root of this would be 4. Take the square root of this, it would be 4. Again, the equations aren't that important. It's just a cool little tool I wanted to show you guys that's on there. So what's the difference in the radius? What is the relationship between the radius and the center? So we would say what I said before, that the radius is the distance away from the center that makes the circle. So write something like that down for this. And then write down what you guys think about circles, if it's hard to understand, stuff like that. That way your teacher can always look at it and see like, oh, maybe we should talk about circles more. Is everybody kind of understanding how to do the circle activity and what circles are? Cool. So again, we're going to talk about line segments and how line segments can be interacted with circles. So if you guys play basketball, the free throw line, how it has they don't have it here. I don't know why they don't have the 3-point line here. They only have the key, but they don't have the 3-point. Oh, that's a terrible 3-point line. Definitely shoot from here if you're shooting for 3 points. But it's showing us where we can do the free throws from and everything. So that's just giving you an example of when we have lines interacting with circles in the real world. All right, so if we're doing this, the circle, point C, 2, 2, is the center of this. What is the ratio of AC? So we're talking about AC. So from this point to a point on the circle, so this we know is our radius, to the point DC. So the point DC is this to here. This is also r. We don't know what it is. We could calculate it out by using the Pythagorean theorem, but what's easier to know is like this is the radius. So the radius divided by the radius, well, that's just going to be 1 divided by 1 because this whole thing just becomes a 1, right? So in other words, it's the same. They're equidistant. So this is just a 1-to-1 ratio. They're the same distance because they're equidistant. So remember when I was talking to you about we have to know what a radius and stuff like that? Knowing equidistance is going to help out. So a circle is always equidistant from its center. So now it's going to talk about perpendicular lines. Perpendicular lines are what's known as a right angle. So this is a 90-degree angle. So that's what it means to be perpendicular. In order to be perpendicular, you have to be at a 90-degree angle. All right, so now, moving on. So now they want us to make these perpendicular angles. So move an angle. Notice that the relationship of that and that. Explain the terms of this. Move point B to different locations of the coordinate plane. What do you notice about the relationship between those lines? Okay, so basically when we click this, it shows us two perpendicular lines. So here we have perpendicular lines, and it wants us to move point B. So we're going to move point B, which is this one. We're going to move this around. Notice how as we move this, because these two lines are always perpendicular, they're always going to be 90 degrees. But this other point right here, this is going to change. So this is a tool that they use in Geogebra for the perpendicular lines. That's why there's all these different tools on this program that helps you do different things. This line will never move, but this line has to be the same relationship. So that's how come I can move this. And this line moves. It has to move because they're perpendicular. Does that make sense? So we'll notice that G and F, this is G and F. G and F always stay at 90 degrees, which means it has to move around. So move point B some more. Notice the difference between AB and CD. So CB, they change because we don't change this line. This line doesn't have a relationship with this line right here. So what's happening is it changes. That angle is always going to change. This angle right here, it's always changing because this has no relationship with that. Describe the relationship between GF and CD. So GF and CD, there is no relationship because we can move this around and it doesn't do anything. We can move this and there really is no relationship. At first, when it was both perpendicular, let me see if I can make them perpendicular again. I can't, so I'm just going to click. I'm going to click this again just to start over. See how they're the same? So at first they were parallel, but the moment we move the B, there's no relationship between those GF and CE. So moving on here, and then just write what you thought about this activity and stuff. Did it challenge you? Things like that. Give yourself a scale. All right. And moving on here. So AB is perpendicular to BC. How many 90-degree angles are formed? This is actually an interesting question because if we have this line makes a perpendicular angle. But remember that a straight line is 90 degrees. So if this is 90 degrees and a straight line, I said 90 degrees, I meant to say 180 degrees. That means that this also makes a 90-degree angle. But this is also a straight line, so this makes another 90-degree angle. But guess what? This is still a straight line. So between this angle and this one also has to be 90 degrees. So what's happening here is we have 4 90-degree angles. Does that make sense? All right, parallel lines. So parallel lines, oops, let me delete my picture, means that these two lines never touch. So when we're talking about freeways and stuff like this, we want them to be parallel because we don't want these streets crossing each other. That we better have a signal light here if they cross each other. So that's what it means by parallel lines. Parallel lines never touch each other. And we're going to see that here. So they want us to do these locations here. So we have these parallel lines. So when we click that parallel lines, we see that we have perpendicular lines here. And we can move this around by using the little arrow if we click on it. We see that we have these perpendicular lines and these two lines are parallel. So basically, if you have a perpendicular line here and this is perpendicular, that means these two lines have to be parallel. They can't touch each other. So let's take a look here. So this is the location of those. So we're going to move point D to these locations. What's going to happen to the measurement of the angle? So let's see here. So I'm going to move it to 12 and 2. So point D is, why doesn't it have the grid lines? I like the grid lines. View. I'm going to put, no, that's not helping. There's a way to put grid lines on here. Well, I'll just have to eyeball it. So right now it's at about 10 and 3. We want to go to 12 and 2. So give me a second. Let me reset this because I don't know what I just did right now. Where I changed this. So I'm just going to click this again. I'm sorry, guys. All right. So I'm going to move this to 12 and 2. So I'm going to move this, go to 12 and 2. So what's going to happen is these angles change. So if these angles change, let's say I keep going over here, over here, over here, over here, these lines eventually cross each other. So they're not parallel anymore. And it's asking us to fill in these angles. So when you guys are doing this activity, make sure you're filling in these angles. Angle F. I like just looking at the middle just to make it easier. So angle F. And we're going to look at this angle right here. So we're going to plug that in. So this is a little bit of work, guys. I would do all of it with you, but since we only have 10 minutes left, I want to make sure we go through the rest of it. If you guys need help doing this, make sure to make an appointment with me and we can just talk about that. Is that cool? Cool. All right. Based on the observations on question 1, what can we say about EA and BF because of these measurements? In this situation, what is the relationship between that? So as we're moving this along, we notice that the angles are changing and then they touch each other eventually. I'm zooming out just so I don't have to move as much. So whenever these angles are not equal to each other, that means that these lines aren't parallel anymore. So see how they're not equal? That means they're going to intersect over here somewhere. They eventually touch each other. So basically, these angles, these inside angles, we'll talk about it later in a later unit. These are alternate interior angles, meaning that they're inside and they're opposite sides. So alternate interior angles. You don't have to remember that right now. I want you guys focusing on line segments and all of that first. What happens when these are equal? When these segments are equal? So you're going to want to measure this to see what happens when these segments are equal. Measure distance when this is equal to this. So we want to try to make these equal. Well, when they're equal, let's see if I can make them equal. Well, let's pretend that when they're equal, we'll notice that these angles are equal to each other. So when the distance between here and here are equal, is this line basically is equal to this line. The angles are equal and they become parallel. So basically, if I go further down the line, if this line is equal to a line over here, that means that they're parallel. So that's what we would conclude from that. If the distance between these two segments are equal, that means the lines have to be parallel. And then again, rate how you guys thought of this activity, what you guys think about it, what you had trouble with, all of that fun stuff. So this is basically just talking about parallel lines. So as long as these two lines never cross each other, these two railroad tracks in this case, never touch each other, that means they're parallel. So they have to have equal distance to be parallel. So the distance between this and over here has to be parallel. Let me use a color or a highlighter. I'll use a highlighter. So the distance between here and like the distance here have to be equal for us to know that these are parallel. If this is smaller, for example, that means eventually they're going to cross over here. If this one is smaller, that means eventually they're going to cross this way. Smaller than this. So that's just what it means by being parallel. It's two lines that are always the same distance apart. So if these two lines are parallel, what's going to happen between this? So if we have line AB, and this is a line. So lines meaning it's going on forever. And line CD, and you'll see that CD, you'll see that they use a different annotation. Before they were saying this is a line segment, this is a line. What about the distance from AC? So the distance from here to there and here to here. Well, these, like I've been saying, these have to be equal to each other. Oh, not equal divided by 2. Oh, they tricked me there. Be careful for that one. They have to be exactly equal. So that's just what it means to be parallel, that these two lines are always that far apart no matter where you're measuring. And when you measure a line, you have to measure to the point where this is equal. You're not going to measure like this. You want to measure at a right angle to make sure you're doing the closest angle. Because obviously, if you make it diagonal, this line is going to be bigger. So if you do it at a right angle, it's the closest distance. This doesn't get any smaller if it's at a right angle. That's why they're called right angles. It's the right way to measure the distance. And I believe that's it. So make sure you're studying what it means for an endpoint, what it means for degrees, measurements, line segments, all of that fun stuff. Did you guys have any questions about the lesson today? All right, cool. Yeah, what's up? Yeah, so it's going to be out on YouTube. So everything that I said is going to be on YouTube. Did you need another video or did you just want a recording of this video? Yeah, this video will be uploaded to YouTube and it's going to be on the Google Classroom as well. All right. Yeah, that way you guys can go rewind, listen to that part. I'm going to make it where you guys have to finish the tutorial and the mastery test by Friday midnight. The reason for that is I want you guys to enjoy your weekend. And if you guys say, I'll just do it in the weekend, you're probably not going to do it in the weekend, you know? So that's why I'm just going to make it due Friday at midnight. So, well, not midnight, Friday at 11:59. That way, you know, I come in Monday morning, I see that you guys did it. If I come in Monday morning and I'm like, hey, they didn't even do it, then that's when I like go like, hey, make sure you're doing your assignments. All right. All right. You guys have a good one. Bye. It went really well. I like it. I'm really glad we're doing this. Mm-hmm. Yeah.